Welcome to the MS SQL Tips webcast. True story. Learn the innovative strategy a Fortune 100 company used to get HA and high performance. Sponsored by Scios Technology. I'm Greg Robidoux, co-founder of MS SQL Tips and today's webcast host. Joining me today is Jeff Heighton, who is a SQL Server consultant and Microsoft MVP. Jeff has extensive SQL Server knowledge back to version 4.2, and today he will share his knowledge about high availability and high performance SQL Server implementations. But before we get started, if you have questions, you can submit them at any time during the webcast by entering your questions in the question area in your presentation controls. And we will try to answer as many questions as possible during today's webcast. If you have any technical issues with the sound or screen quality during the webcast, also use the question area to let us know. If you're not already a member of the MS SQL Tips community, we invite you to join. You can go to www.mssqltips.com and sign up for our newsletter, read any of our tips, download white papers, and watch any of our archived webcasts. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's webcast. So at this time, I'm going to turn things over to Jeff, and he can get started.
Thank you, Greg. Scios and MS SQL Tips asked me to come up with a good story, a nice tales from the field about how Scios and DataKeeper product works in real life. And I had the fortune to work with a system last year, a Fortune 100 company that had a fairly unusual infrastructure requirement. And ultimately, the Scios DataKeeper product was a key piece of it. During this presentation, I'm going to talk about some of the requirements and why the Scios DataKeeper fit pretty much uniquely as a key part of the solution. So let's look at what Scios does. Anytime we're talking about high availability in the Microsoft world, we're talking about Windows Server failover clustering. And clustering is more than just the storage arbitration. Nowadays, it is a distributed failure detection and management framework. But you still have to have some type of shared storage for most applications. We have SQL Server, Link, SharePoint, Dynamics, all these other ones. We can also do this in a cloud environment. We don't have to have the traditional SAN anymore. Best part of that is, of course, you don't have a traditional SAN administrator that tells you you can't have that much storage, you're going to get thin provisioned. You can put the I/O subsystem under it that you want to have and still have the high availability solution. That was a key element of this particular problem. Let's go on and look at exactly what we were trying to do here. The business need was a very large company, but like many large companies today, it was really many small operating companies behind the scenes with certain pieces of it unified. Finance, IT, many of the other common HR, a lot of the common elements were one company, but there was a tremendous number of small operating companies that all needed this same information. They needed a unified BI system. But because they were individual operating companies, we needed to be able to handle the local exceptions to this. As most people will tell you, Excel is the #1 BI tool in the world. We do more analysis in Excel than anything else, and pretty much everything else put together. And so that was how the data had to be presented to the midline business managers. That's what they knew, that's what they were going to do. Trying to come up with any other presentation tool, even though the graphs are prettier and the drill down is cool and a lot of other stuff is neat, Excel was going to be the answer. That was just a starting premise. And finally, this had to be rock solid. Everything had to be ready first thing in the morning, technically 8 a.m. Eastern time zone, every single day. This was very much real-time feedback on operations information that was necessary for this business. They really hadn't been able to have a good answer to this before. Now I know most of you that have heard me before wonder what is this OLTP guy doing talking about BI? Well, the scale of the BI system that we had and the requirements almost brought it back into the realm of OLTP in terms of what we traditionally evaluate for performance, scalability, and availability. So most of the skills that I've developed in keeping OLTP systems up and running were highly, highly applicable to the infrastructure for this particular solution. So let's review clustering real quick so we can see how this all fits together. In a traditional failover clustering, you have application, you have some type of LAN, you have some type of shared storage in the middle. With Scios, SANless clustering, you don't have that. You don't have that single point of failure. You don't have the consolidated storage. If anybody ever tells you that SANs are all about performance, ask them what they're smoking, because they got the good stuff. It's not about performance, and it never has been. It's all about storage consolidation. It's all about return on investment, saving money, storage management. A lot of people like to synchronize backups through snapshots on the SAN. Personally, I'm not a big fan of that, because that still keeps all of your systems, your backups, and your primaries in the exact same box and a single physical and logical point of failure. I've never been a big fan of SANs. I've been trained to manage several different brands by their manufacturers, and I'm still not a fan of them. They're kind of a necessary evil for high availability. At least they were before we ended up with SANless clustering with Scios DataKeeper. Now we can use a stronger and multi-connected network to replicate data between servers. Very low latency. It's done at the block layer, so unlike things like NFS, we don't have to worry about files closing. So for a file server, this is an awesome solution. I can do this synchronous or asynchronous depending on how my network is. Even if I have fast connections, if I'm going on a WAN, my latency may be high enough that I don't want to do a synchronous connection. That may put too much back pressure on the primary server. Now, if I'm sitting next to each other in a rack and I am highly connected, we'll show an example of that later, I can want that full protection from synchronous commit. And failover works just exactly like failover always has worked in the SQL Server world with failover clustering instances. The fact that there's unique storage under there doesn't matter. The Scios DataKeeper product presents as clustered storage and works exactly as clustered storage is expected to. Same thing for Hyper-V. Basically, any workload that I want to put on top of the Scios DataKeeper is any workload that I would put on top of a normal failover cluster. So I can do Hyper-V. I can do this multi-site. Same with SQL or Hyper-V workloads. I can have multiple replicas, and I can set up each replica with a different connection. I can make the local rack failover synchronous, and I can make the long-term ones, or the distance ones, asynchronous. One solution to fit both my local HA and my distance DR requirements. And that distance can also be cloud. I don't have to have a physical DR. I can make that a logical, virtual DR. And here's where this slide I particularly like, because this is telling us exactly why I chose Scios DataKeeper as a key element of my solution. Needed that high availability for business critical applications, especially without a SAN. There was a couple of reasons we weren't able to use SAN technology in this. I'll go into that in the details. Flexibility. We needed, with Windows, Linux, physical, virtual, cloud. Our solution in this example is purely physical. The second one, though, the third one, sorry, is absolutely critical. High performance. I needed something that screamed. We had a lot of data to move around. We had a lot of stuff to do. We had very poor application queries and performance, and I needed something that was going to maximize the hardware performance that I got. The TCO, data center efficiency, that was a big part of it. There was no way we could do this with pretty much any existing technology. This was kind of a unique solution for us. Application awareness, and finally the data center leveraging or enables enterprises to leverage the new data center. We initially started this out with just a local high availability, but we were always asked to keep a possible DR scenario in mind, because that's something that the entire organization is looking at, and any new projects at least had to mention DR and address the capabilities of it, and what would you do and how would it work if you were asked to extend this into a DR. So we had to have a section in the design document that discussed, if you want DR, here's the way you can extend this solution. And Scios offered us the ability to extend that section of the solution into the cloud space if we needed it. All right. Real quick review here. Fully integrated with clustering. This was a SQL, but not just the SQL Server engine. We were actually protecting analysis services with this. Very fast, very low overhead, and tunable. We could make this thing work exactly the way we wanted to for our specific needs. Now here's where it came in, the supported local storage with the solid state drives. One of the things we did with our system to give it a fast system was use solid state drives. I've got a slide later on that shows you the system configurations and what we did to make these things go really, really, really fast. We didn't need the shared storage, and we were fortunate to build this on the latest and greatest of the operating systems, Windows Server 2012 R2. But if your needs are to support something with a different technology matrix, that's fine. It'll work for you just as well. Okay, so let's look back at our business need again. One time, again, a very, very big company. This was a Fortune 100. Let's call them Acme, just so that I don't slip up and give you the actual name. They would be unhappy with that. So Acme needed a unified BI system. We were partnering with another consulting company that did a lot of the business analysis and had already developed a set of spreadsheets and a SQL Server analysis cube. They needed to be able to take that processing line of getting the data, updating the cube, updating the reports, and getting this out to the line managers on a daily basis. And that sounds really easy until you realize just how big a problem this is. Let's look at our particular challenges to do this. This is what made it tough. First of all, scalability. As anybody who's ever connected Excel to SQL or to analysis services understands, Excel writes some of the worst possible queries in the world, especially when we were looking at all of the exceptions that we required because of all of the local optimization for each of the different operating companies. That meant that we were going to have some serious horsepower on the back end to support all of the queries. Performance, we had those tight reporting deadlines. We had to have a series of, I want to say, between 25 and 40 stock reports done every morning by 8 o'clock and available on a portal. Infrastructure. This was interesting. We were not going to get a SAN. And there was a couple of reasons of this. One of them, unfortunately, was a little bit of politics. We were coming in backed by the finance team, and the IT team had an alternative and competing solution, so we were actually kind of swimming upstream against the existing IT system. Fortunately, that resistance only presented itself at the management level. The guys that were helping put this together, they were, well, like you and me, we're kind of tech geeks. They got into the solution. They got into the idea of, hey, this is kind of cool and unique, and so they were extremely helpful, and we were able to solve quite a few problems. But one of them was they were actually out of SAN space, at least, and I tend to believe them. I saw a rack sitting there with a blade center totally powered down and unplugged, and when I asked them about it, they said, yeah, we don't have the SAN space to bring up the VMs. So and they weren't going to buy one for another 8 or 9 months at least, because that was their purchasing cycle for storage. Sometimes the ways and means of large companies confuse me. I don't always see what they do and make sense, but then again, I don't run them. All I'm doing is trying to solve particular problems. And in our case, it boiled down to, you're not getting a SAN. Okay, we're not getting a SAN. Availability, this was business critical. This had to run. It had to be there every day. Part of the mandate was this was going to be how they were going to operate and make decisions for their business. So it had to run. It had to be every bit as available as any core business OLTP system. The cube size. Now this is what gets it also challenging. This was a big company, a lot of pieces and parts, and we had about a 250 gig cube. Now this is an analysis services tabular mode cube. That's the memory footprint of the cube. This wasn't just a traditional mode, multidimensional. This was the full in-memory version of analysis services. So our starting cube size was about 250 gigabytes. Yeah, this was not going to be easy. And when I was talking about the SAN, I was talking about they had a multi-month timeline, or an 8-9 month timeline at least to buy a SAN. Most of the projects were measured in months, sometimes years. We had weeks to do this. This was something that they wanted and was being driven really, really hard by upper management, by finance, and if it didn't work within a certain time period, they were just going to go with another solution. We were competing to try and make this thing work and show the business value of it. And finally, it all just had to work. We couldn't have something that had a lot of individual hand-holding, maintenance time. It had to work just like any other core IT system, except we weren't going to be able to get a lot of people assigned to it to maintain it. It had to be very much self-sustaining. So how did we meet all these particular challenges? This is where the solution comes in. Really quick, let's look at why AlwaysOn Failover cluster with a Scios DataKeeper cluster edition was really the right way to go with this. Standard edition wasn't really an issue. We were using enterprise because that's the only way you're going to get analysis services. Distributed transactions, yes, we had multiple databases to deal with. Unlimited databases, we weren't hitting a huge limit, but it was something that was pretty important. The automated client redirection was essential. System databases, so it was one system. We didn't have this multi-node thing to administer. The really key one, though, is the fourth one from the bottom. Replicates data other than SQL. And by SQL, most of the time we're talking about the SQL Server database engine. Well, in this case, we're also talking about SQL Server analysis services. SQL Server analysis services doesn't have an analog to the AlwaysOn availability groups. We can't push data in there. The only way we can do this is either manually set up some type of synchronization process or to create or use some type of shared storage. So that was one of the absolute key pieces. I had to be able to protect workloads other than the core SQL engine to get high availability. Also, taking out the SAN is a single point of failure, or just completely eliminate the SAN, because again, we weren't going to get a SAN with this. Quite frankly, I was pretty glad, because I don't think I would have been able to get the performance levels I've gotten with almost any SAN on the market today. And when you see how I built out the machines, you'll understand why I make that claim. This was another piece of it. A few years ago, David Birmingham, one of our panelists here, did some comparisons with a PCI flash memory versus the different ways of protecting that. So the raw system, here you see we hit a little over 1 million I/O ops. This is on a commodity box. When we engaged the Scios DataKeeper, we lost about 10, maybe 11% off the top, which for block replication is actually very, very good to have a protected workload. And then we tried to do this with SQL Server AlwaysOn availability groups, and we got quite a bit less performance out of the system. We hit bottlenecks with networking, we hit bottlenecks with other pieces, and it just didn't help as much. And these are on data inserts, so this is basically pouring data in as fast as you can. When I was designing this system, I remembered this. This was, I remember, done on a SQL 2012. We were building a SQL 2014, but I remembered this slide. I said, this is why I need Scios. I need to be able to keep this performance up. Because I've built these machines as best I know how for maximum speed and performance. And I didn't need to sacrifice that just to get high availability, but I still had to have high availability. Okay, so here's what we did. This is a small piece of our design. So for starting at the top here, we had SQL production systems. These were what we refer to as our Class A systems. These were based on the Dell PowerEdge R730 platform, a commodity server that we're all probably familiar with. We used the 2667 Intel Xeons. This gave us the highest processor frequency we could possibly get at the core count we were looking for. We put 768 gig of RAM into each of these particular machines. Now these Class A machines are the first four that you see. These are the SQL production machines and the SSAS tabular cube production machines. There's a bunch of other pieces to the diagram. First of all, there's the staging, UAT, staging, QA, those levels. There's also the pieces that held the virtual machines with running the Excel reports for the pre-done systems. And there's a couple of machines that we call the orchestrator that drove all of this stuff. But the two main processing areas are the SQL production nodes and our cluster, and the SSAS tabular cube cluster. If you look at the storage on these things, I was running 10 1.6 gigabyte SSD RAID 10 mixed-use SAS drives, or sorry, mixed-use solid-state drives. And then the network for the Class A's was teamed 4 each 10 gig NICs. I did not want network bottlenecks, and I did not want storage bottlenecks, at least not ones that were anything that we would consider a normal bottleneck. So these things were extremely well connected. Now the production system had a lot of data coming into it from other systems, including AS400 systems, other OLTP systems, other aggregation data repositories. That was where everything came together. I think we ended up with about 5.5 terabytes of total data footprint on the production boxes. Now that went over to the SSAS tabular cube processing boxes. Now the processing boxes, the only job they had was to actually process and host the cube and to serve as the source for the scale-out farm. This is where we get into that rightmost little box that says times 18. We had 18 clone servers, each of them with 5 800 gig SSDs to give us about 4 terabytes of usable storage. And yes, I did those at RAID 0 intentionally. With 18 clones, that became my high availability. If I lost a drive, I lost a clone. But the clone only held a copy of the data. The master copy was protected on a highly available, highly redundant system, the tabular cube processing nodes. The networking on these were only dual 10 gigs. And we actually put these behind a load balancer. We wrote a custom application to manage all this stuff, to refresh the data, to manage the load balancer, to refresh all of the reports. We had a lot of complicated pieces in there. For example, on the report side, we had 2 different pools, even though they had the same machines underneath them. We had one pool for our automated reports and one pool for our user level reports. And starting as soon as we got the data refresh, which was typically around 6 or 6:30, we pulled, once we'd refreshed all of them, and we managed the refresh so that there was only one version of the truth out there at any given moment. So there was old data, and we would pull out anyone that was being refreshed, and then we would do a quick switch behind the load balancer so that it didn't matter which machine you got, you always got there's all machines that were active in the load balancer at any given moment always had the same cube on them exactly. We even had it pretty smart so that if we couldn't do a sync with the cubes, we did a full backup restore. I managed to do some testing on this as we built it out. I was literally running all of my file copies at full wire speed. My disks were never, ever a storage or the storage layer was never, ever a bottleneck. We were actually running at 10 gig wire speeds for everything. And if you're familiar with the networking options in Windows Server, we chose the ones where basically a single connection could only consume a single NIC. Again, with 18 machines out there, I wanted everybody to have kind of a fair slice of everything. I didn't want one machine to be able to suck up all of the connections to another machine. Our refresh was even smarter, so that once a clone became a refresh, once a clone was refreshed, it could actually be a source for somebody else's refresh. So we didn't have all 18 of them going back to the original source. We had 18 of them. We had a few. I think we restricted these to, I think 3 or 4 at a time was the maximum we could pull smoothly off of the production. But we had a tuning factor that said what's the maximum you can pull off of anybody. And so we kind of leveled that out so no machine got saturated and got slowed down by that. And we were able to do a refresh, multi-layer refresh, fairly quickly. Originally we had the design for 30 machines, but it turned out to be these were a little bit faster and more powerful than we had estimated, and were able to support a larger workload. So we pared it down. The first round of machines, we had 8 of them, and then the second round, when we extended the solution out through the entire company, we added another 10, and that's been holding up very well. So let's talk about the solution elements. Custom code. We did DevOps style custom code management for managing all of our refresh, load balancer status, everything. So this was one of the key elements that we weren't going to be able to get a lot of people to support this extra solution. Fast, robust networking, and I got to really hand it to Acme's network guys. They stepped up and really helped me design a truly robust network. All of the machines are basically divided into 2 racks. Everything's cross-rack connected. We can lose a single switch element, and everything still works. Fast storage and super hot processors, 8-core processors, so that gives us 16 physical cores. We did turn on hyper-threading on this one. Logical 32 cores per box, and there are times that we're running them 80, 90, 100% to solve a single query because the queries are so bad. Good memory, 768 gig apiece. This gives us plenty of room to process the cubes, hold the cubes in memory, everything. And then finally, the Scios DataKeeper. This was essential to get the high availability on the data processing side. The clones are great. They exist most of the time. I could lose one and I don't care. The load balancer takes it out and deals with it. But when it comes to those processing nodes, either the SQL side or the analysis services, I had to have that running, especially the SQL side. That was actually pulling in data all day and updating its internal tables. And then finally we would do a cube refresh once a day, typically once a day, although they did say they might want to do it more often. But we did cube refreshes once a day. We had to have highly available systems. We had to have stuff that transparently failed over. We didn't have time to do a standby and have somebody configure it. This just had to run. So the Scios DataKeeper allowed me to configure a system with this level of performance, with this kind of I/O and network capacity, without breaking well, either hammering a SAN into the cold ground, or being limited by what a SAN would do, or having that single point of failure. Now I'm able to have a system that has no single element of failure anywhere in the entire platform. Heck, even the load balancers are clustered and paired. Again, we don't show those. They were already in the infrastructure. We just leveraged what they already had. But if anything breaks, any of the VMs, we spin up another one, or it automatically moves to another host. For the Excel piece of it, everything, literally every single element has automatic failover redundancy, and the biggest piece of that is the Scios DataKeeper product, giving me that at the storage or at the SQL and the SSAS layer. Let's pause for a second before we go on. Has anybody got any questions about this particular solution? I know we don't want to do questions a little further on, but has anybody got any comments or questions about this? Because I spent a big chunk of last year designing and building this, and as you can tell, I'm kind of proud of it. But opportunities like this don't really come along very often in a career. Usually you're doing small and medium stuff. When you have something with this size, I mean, you look at the systems, just do some basic math here. I've got 16 cores and 20 systems from a licensing standpoint. So I've got 320 SQL core licenses. You can go to the Microsoft licensing site and figure out the retail price of that. Obviously these guys get a bigger discount, but when your licensing costs alone exceed $1 million, it's a big project. It really is. And I don't know about you, but I enjoy big challenges and working on big projects. So again, Greg, has anybody popped in with any questions yet?
Yeah, there's a few questions here. So one person asked a question about, does the replication use synchronous or asynchronous mode to replicate the data?
In our solution, we used synchronous because we wanted it to be completely protected. We didn't want anything to go wrong. We had the infrastructure and storage systems to do that, but with the Scios product, we could have used asynchronous. And if we were going to extend this to a DR solution, we would have very likely used an asynchronous solution because I wouldn't have had the network bandwidth to support that much data going that fast outside the system.
Okay, and another question someone asked was about the performance on the network, just the replication throughput, and then also kind of follow up with that is, was there any particular different NIC cards that were used to be able to push this much data through?
I believe we used add-on cards, obviously, because the 730s come with 1 gig NICs, but they're built in, I think, 4 of them. We did not. We originally were going to use those as management, but the networking guys were once they saw how the Windows networking worked, and I saw how their stuff was going, we eliminated that. We did everything through the 10 gig connectors. It just simplified it all for us. So we used Microsoft Windows switch independent network teaming, built into the 2012 R2 product. And those guys, we did most of the connections internally between the machine, or all the connections internally are what we talked about. Up to the rest of the world, I think, is like a single 10 gig connection out of our core or our subnet area. We knew the rest of the world didn't need quite as much connection, interconnectivity as we did. But I think we used Intel cards for these. The optional Intel NIC cards from Dell. So, but these were not anything other than just 10 gig with 10 gig switches behind them. We didn't use anything like Rocky or any of the super advanced networking. We just threw a lot of commodity solution at it.
All right, and then another question was related to the processors. We can just kind of reiterate the number of processors and logical processors, and you also mentioned hyper-threading as well.
Yeah, we actually did some testing on this. One of the things we had with the luxury, a little bit of luxury, we were able to, we spun up the clones first, and we were able to use a couple of them while we were still doing some development as test platforms. So I could see how they worked in different configurations. We picked processors that were extremely powerful. We knew that a lot of the solutions we had didn't handle multi-thread as well as we wanted to, so we knew we were going to need some very, very powerful processors. If you want an in-depth discussion of processors in SQL, I recommend Glenn Berry's blogs over on SQL Skills. He has some very good in-depth information about all of this, and I followed his advice at the time, and I went with what I felt was a good balance with number of cores versus the clock speed. Given the pricing of SQL licensing these days, your single most expensive component typically in a system is going to be the license. In this case, because we were using some fairly pricey SSDs, that wasn't exactly the case, but you're still paying one of the biggest single items is going to be SQL licensing. And it makes sense, especially if you're having to use Enterprise Edition. If you're doing that, it makes sense to put the best hardware you can afford underneath that to extract the most value out of each license. You'd much rather go buy a more powerful processor, more powerful systems, than to have to go buy more licenses. It's just a brutal fact of the way the product is licensed these days. You need to do everything you can to extract value. In some cases, that means getting away with things that you would normally need Enterprise with, but being able to do it in Standard Edition. It's one of the reasons I like Scios when I'm on a budget project, a really tight budget project. I can create a 2-node cluster with Scios DataKeeper without a SAN, which saves quite a bit of money, without having to jump up to Enterprise Edition. So I can leverage 2 different cost savings, not Enterprise and not SAN, and still have a reasonably highly available solution with the Scios DataKeeper product. Since we're talking about processors, let me talk about memory for a second, because this was something that we ended up with quite a bit. One of the interesting notes about SQL Server Analysis Services is that it is not NUMA aware. And for those that aren't familiar with NUMA, it's just simply how the memory and processors relate to each other. NUMA is non-uniform memory access. That means that every cell of memory does not necessarily take the same amount of time to access as all the other cells of memory. In the case of the R730s, there are 2 physical processors, so there are 2 NUMA nodes. Memory that's local to the processor is faster than memory that's not. SQL Server is NUMA aware and will manage threads and memory to try to keep everything as local as possible. Analysis services isn't. And there were some writings from Microsoft on how NUMA crossing boundaries affected performance. So what we did is we actually configured the machines a couple of different ways. We configured them where they did have a normal NUMA boundary, which was basically side A, side B, if you want to call it, and trying to see how we could do this, testing it at various performance, what the performance impact was. One of the other ways you can manage NUMA is to interleave your memory so that block 1 is from processor A and block 2 is from processor B and back and forth, which kind of randomizes it. You're going to be crossing about half the time and half the time not. Ultimately, that was the configuration we set on. We knew we could actually make it slightly faster some of the time, but at the risk of going considerably slower at other times. And so we opted for reasonably fast but consistent with NUMA interleave. We ran quite a few tests on that using some sample queries that we derived from the stock reports. So this wasn't just a generic benchmark that we went off of. This was actual numbers that we ran for our particular configuration that were these queries, which we felt were representative of the workload. How are these going to perform? Anytime you're doing something like this, it's important to go ahead and do that kind of benchmarking, even if it's not even if you're not trying to figure out different configurations, just so that you know how much each thing takes, so that as you monitor this over time, you can see, is it continuing to meet your performance goals or not, or is something growing out of proportion with the workload growth, and you need to address that and maybe remediate something that you've engineered a weakness into the system with. All right, let's move on. So, who is this Scios, folks? These are I've been actually working with Scios one way or another for many years, and they've been around much longer than I've been working with them. Obviously, they're a gold application development partner, but if you look at all the names and companies they've worked with, it's a pretty impressive list of partners. This isn't something that they just thought up last week. This is a product that they've had for a while. They've had quite a bit of time to improve and refine this, not just in the Windows world, but in the Linux world. They're actually able to feed back and forth knowledge from the two environments. So that's one of the reasons that I'm a big fan of this particular product. Going back to our original requirements, it just works. The company's been around since 1999. As I said, they've been here. This isn't something they just invented last week. They're based out of San Mateo, but they got offices all around different places: U.S., U.K., Japan. I'm sure this isn't the first time many of you have heard of them. They've been doing this for quite some time. David, how long have you been working with these? Working at Scios? Because I know you've been there for a very long time, or fairly long time.
Yeah, 12 years now.
Yeah. So you know, they're again, this is not a startup. This is a well-established company with a strong reputation. 50,000 licenses in just about any place you could possibly imagine. And again, their partners are some of the names that we interact with, deal with, say sometimes nice things, sometimes not so nice things about every single day. So anyway, that's my story for the moment. Do we have any more questions, Greg?
Yep, there's a few more, and if people have other questions, feel free to type them in, and we'll get to as many questions as we can. All right, so one question goes back to that slide you were on earlier, Jeff, and you talked about the custom code. So somebody's just wondering if you can kind of expand upon the custom code.
Let me back up to that real quick. You're talking about this, right?
Yep, so they're just wondering, you know, what was it written in? Was it PowerShell, C#? Kind of explain a little bit what you did there in custom code that you created.
Yeah, originally we were just going to do some PowerShell for managing the refresh, and then it got a little more complicated. We ended up writing a .NET application. We call it Orchestrator because we don't have much imagination. and it has multiple tasks. Part of it is to drive the ETL process and make sure that those tasks are done. So one element is its ability to look at success failure for SQL jobs, SQL agent jobs. So it goes and looks at those, everything done, everything ready, okay, good. Then it drives a refresh for the primary queue processing and lets that run. And that, of course, hammers those machines pretty hard. Once that's done, we take half the machines out of the load balancer. We start the refresh cycle. We let that settle. Now the refresh is normally a synchronized process because that's going to be a little faster. It's an incremental update. It's part of the SSAS tabular functionality. If that fails or does not complete within a specified time period, it aborts that, drops the cube on that particular clone, and does a refresh, does a restore. Because as we are starting to synchronize, we're also running a backup of the cube from the primary system. Just a local disk backup straight to the local pieces, because we don't really care about backing it up for archive. We're looking at backing it up as a means of populating the clones. Once we have the half of the clones done, or we may end up with, I think there's a factor that says good enough. I think in this case, if we get 7 out of 9, I believe we'll go ahead and do the flip. We flip them out. We take the existing ones out of the load balancer, put the new ones in at a single whack, and then go refresh those, bring them back in. As we have those new ones in, we begin ramping up the automated, or we also manage the pools. I told you we cut down the user pool down to 2 machines. We turn up the automated pool to everything, or at least all of the ones that are active in the load balancer, and start the automated refresh. We start some of the longest running reports at the beginning so that they have this, because they're only going to run, remember the reports run against 1 machine. So and as we've determined how many, based on how many machines are back in the load balancer, how many reports we can run at any given moment. We also have a robust monitoring system. We started with the SQL Sentry product and leveraged a few extras on top of that with some custom work to monitor what's going on and react appropriately. But anyway, once we get everything, and as we start bringing machines back into the load balancer, we start ramping up the reports. And once all the reports are done, we go ahead and open up the user pool again. So it's a fairly robust system. I kind of helped with the logic on it, but our app dev division actually wrote the pieces of it. I do know there's a coordinator piece, and there's a small stub application, a receiver on each of the host computers.
Okay, great. The next question is related to Tempdb, and so we're just wondering, did you run into any issues with Tempdb or your configuration, or did that play at all into the model of what you designed and how well things worked?
Yeah, obviously Tempdb only applies to the primary system. We looked at the different possible disk configurations, trying to maybe do isolated disks for everything, and ultimately we came back to, if we put all these enterprise SSDs into a RAID 10 configuration, we're going to get some seriously fast I/O operations, and so we did. And any other configurations lessened our flexibility in terms of how much data we had, what size we had. Did we size it enough? Everything else. This gave us the most flexibility in the storage, as well as the best possible performance. I'm given time, I could probably have tweaked it to a few percentage points for maybe a little bit for a static workload. But again, we were rolling out a solution across the company. We didn't have all the answers up front. We didn't know everything that would happen at scale. We've done some pretty solid research and some careful mathematics. But as anybody knows, that as things upsize, sometimes they don't go as linear as you think they are. Sometimes they're inflection points. So we gave ourselves enough flexibility that we could have whatever we needed. We did have to create a pretty decent size Tempdb. We did the multiple file tricks and everything that you're used to seeing. but we didn't do anything other than just say we're going to give us this super duper fast storage pool with all these drives, and that seems to work. Now, one thing we do have is these are showing just the SQL data drives. We actually have a separate dual set of 300, 600 gigs, something like that, rotating disks as the boot drives, because once you've got it booted up, you don't need them to be fast anyway.
All right, let's see. The next question here, Jeff, is related to the use of Excel, and you mentioned the port queries. They're just wondering, was any time taken to kind of optimize some of the queries and how Excel interacted with the databases, or?
Unfortunately, not really. The Excel generates a lot of that stuff when you do the external data source, and there just wasn't. We looked at it and we went, oh boy, these are ugly. But ultimately, that was what they needed to get the queries the business, or to pull the data the business needed in the form they needed. And a lot of times we try to optimize stuff like that, and sometimes you have to because it's simply impossible for the system to respond in a reasonable amount of time. But in this case, the idea was we needed to get data to the people that were using it in the form they wanted to use it. And the plumbing behind the scenes had to adapt. And if that meant we had to support terribly, horribly ugly queries, then that's what we had to do. We looked at some of them, tried to tune some of them, but they really didn't offer a lot of optimizations. Remember, these are tabular mode. These are querying. These are what DAX queries. That's it. Well, I kept wanting to say MDX, but they're not. No, they were DAX queries going into tabular mode. So they just, that's normally something that I'm a big fan of is query tuning. It's a lot of fun. It's enjoyable, and you see a big impact. In this case, we just didn't have a lot of opportunity for that because of the constraints we were working under.
Okay, and that follows up to this next question. I think you mentioned some of this earlier on, but somebody just asked a question about, why didn't you use a dedicated SAN or storage solution to kind of solve some of these issues? And
yeah, we looked at that at one point. As a matter of fact, one of the early iterations of the design had a SAN. We were going to use SAN replication to try and populate the clones and just let them do that. We realized that all that's going to do is it's going to give us one set of disks under the covers and then a virtual representation, and everybody's going to be hammering those disks at the same time. That the SAN is really going to have problems because you're not going to have 250 gig of cache in a SAN. So it's going to be going back to whatever storage media, either SAN, either rotating disks or solid state. And we had some ideas, especially some of the new full solid state performance SANs. And one of the things we ran into is we are a particular vendor SAN shop. Full stop, end of discussion. If it says it's a SAN, it comes from this vendor, no matter what. And they're not buying anything from that vendor for 8 or 9 months. So the early ideas of having a SAN and having a shared storage got hammered out for 2 reasons. Number one, we were very concerned about the shared storage, the shared aspect of the shared storage, both from an availability and a performance standpoint. And when we started interacting a little tighter with the company, they go, well, that's a nice idea, but we don't do that here. And there's certain things that certain ideas you can present and argue and discuss with Fortune 100 IT companies, and there are some things that you can't. And part of being an architect is understanding the arguments that you don't get to win.
all right, so here's the next question, Jeff. It's not necessarily related to the project so much, but the use of DataKeeper, and just somebody was wondering here if you have any experience using DataKeeper in Azure for failover cluster, and I'm not sure if you can answer that, or maybe Dave Birmingham can answer that question.
I've done it in a couple of experimental tests. I haven't actually built a production system like that. I believe David has supported several production systems like that, though. I'll let David address that question.
Yeah, thanks, Jeff. Yeah, absolutely. So DataKeeper in Azure, you'll probably seen this in the Azure Marketplace. So it's a fully certified solution for Azure. We're seeing a lot of uptake, tremendous amount of uptake. So I'm talking to customers, multiple customers every week that are moving workloads into Azure. So absolutely, if that's something that is of interest to you, definitely reach out to us and we'll get you started on that process.
Speaking of Azure, one of the again early pieces I had done to this was a option for doing all of this in Azure. The idea being that if we turn off and decommission clones when they're not in use, we can bring the working set down, and we can save. I was estimating at least 50% on the licensing costs over a 3-year run. I was also informed that they don't use Azure; they use a different cloud platform. Again, full stop, end of discussion, no arguments. So again, sometimes these aren't the ideal design that you want. Sometimes you end up, I always talk that IT, our job here is really to manage compromise. We have requirements, we have budgets, we have constraints, and sometimes those constraints are logical and reasonable, and sometimes they appear unreasonable to us, or at least we don't understand the business reasons behind those constraints. So we just have to manage imperfection.
Okay, Jeff, next question here, and this is more general nature, maybe not specific to your particular project, but you do have a lot of experience here. The question is related to doing the queue processing, using SQL Server jobs to run the processing to build the queues. They're just wondering, does this add a lot of performance overhead from a SaaS perspective or a SQL Server perspective or both? So if you can kind of maybe discuss that a little bit.
How you fire off the refresh doesn't matter. I mean, it's a single command in there that says, go get your data, or essentially is what it's doing. So if you actually look at a SQL Server job to update a cube, all it's doing is wrapping a single command. How you fire that off, whether you fire it from jobs or whether you fire it from a custom orchestrator app, doesn't really matter. It's all the same because it's the cube engine that's going out and pulling the data and doing it. It's querying the SQL Server, and that, of course, has massive impacts. Anytime you're updating cubes, it's just going to hammer your SQL Server. There's no way to avoid that. That's why we had a dedicated repository server that brought all the data together so that we didn't hammer everybody else's system apart. We can control the data feed, control the data feeds into there reasonably well with timed updates and performance window management and all of that stuff. And that was how we kept from dragging down all of the rest of the IT infrastructure systems. We put everything on that one big box and then just hammered the daylights out of it, which is why we built it the way we did with the storage, the processors, the memory, and DataKeeper.
All right, this next question is related to memory, and they're just wondering, how do you determine how much memory for the box? Was it just limitations? Was it cost? Was there some way you figured that out based on the size of the data? How much memory would be utilized?
I think we could go more memory, but it was going to have to run the 64 gig DIMMs. This is as big as you can build one of those boxes with 32 gig DIMMs. And given the cube size, we'd estimated the cube was probably never going to get over about 340 gig. And as long as you've got double that, you can do the sync. Because the sync basically doubles the memory footprint temporarily. If we ever went over that, we would have to drop the ability to sync and simply do a backup restore every time. But we looked at the maximum growth numbers of what we would need for the SSAS cube and the processing and managing and everything of it, and that corresponded with the very big price difference between 32 and 64 gig DIMMs. So that's what we went with.
Okay, and then there's a follow-up question to that as well. Oh, I'm sorry.
Just because we had a big budget didn't mean that we didn't try to make the most out of everything that we had. We tried to put the right amount of memory in it. Like, for example, the storage, going with RAID 0 on the clones saved quite a bit of money. That was 18 drives to get this, or 18 800 gig drives, and Dell does not give those things away. So we were able to come up with some, and then demonstrated cost savings in this, that hey, we weren't running with a stupid budget. We needed this to solve the problem. This is all we needed to solve the problem.
Okay, and actually there was a follow-up question on the memory. They're just wondering how much memory did actually the system end up using after you guys did deploy the cube?
Well, that the cube footprint is pretty much the in-memory footprint of it. There's a few gig here and there for the OS overhead and SQL analysis services overhead, but the biggest piece, because SSAS tabular is an in-memory, you look at how much memory it uses and go, oh, that's how big my cube is. So, or actually, you run it empty and say, okay, how much does it use, and then how much with the cube in place. Technically, there were 3 cubes in there, but one of them was the biggest one, and we just talked about the aggregated footprint of everything. It's easier that way. Yeah, we look at the memory usage. Again, that's one of the things that the SQL Sentry product helped us with, is looking at the memory usage of the machines, the user uptake of this. We actually added a cube onto their database to pull out user data so that we could validate the user uptake of the system.
All right.
Promise they use it. Well, if we didn't see 10 people logging in that morning, we were like, okay, what'd you do, guys?
Okay. All right. The next question is just related to the size of the cube that you had, and they're just wondering how long did it take to process that, and were there any things you went through to speed up processing to make it complete faster?
That's part of the refresh orchestration. Honestly, I don't remember the exact refresh time on that. I probably could come up with that number, digging in a little bit. The overall goal was, again, 8 o'clock in the morning, and yeah, we tried to do everything we could to speed that up. The problem is we weren't able to redesign the cube drastically. We did have some input in that. We were able to make a few changes to get some performance increase in there, again, we were kind of handed here's a solution, scale it out and make it fit, and so we did.
All right. Well, I think we hit all the questions. So I guess before we close, is there any words of wisdom you want to share with everybody? Kind of, if they take on a project of this size, of kind of where to start and where to go?
Don't let the obstacles get to you. Anytime you have something like this, you'll run into challenges, you'll run into difficulties. Some of those are technical, most of those are not. And just, don't take it personally. People like me, people like most of us, really get into doing this. We kind of own the solution. It becomes our baby. You still have to have that level of passion, but you can't let the obstacles and the opposition get to you. Approach it with good humor and enjoy the ride. And even on a bad day, there are worse ways to earn a living.
All right. Well, great. Thank you very much, Jeff, for sharing all that information. It's definitely good to hear real-world scenarios and kind of what people have faced and how they overcome some of the challenges. I also want to thank Scios for sponsoring today's event. So please visit Scios at us.scios.com to learn about all of their SQL Server HA solutions. The webcast was recorded, and you'll receive a follow-up email with links to view the archive, and we'll get a copy of the slides for you as well that you can download. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.